Ignite your curiosity with Austin Next. We're watching Austin transform from a thriving ecosystem into a global superstar. With our host, Jason Scharf, we aspire to better comprehend the true nature of innovation. Together, we will uncover what makes a successful ecosystem and navigate the technologies shaping our future. Now let's dive into what's next.
Today's podcast is sponsored by Austin Private Wealth, a registered investment advisor focused on fee-only financial planning and investment management. Their mission is to serve affluent clients with personalized financial advice, fostering a trusted relationship that will endure for generations to come. Austin Private Wealth is not just about managing wealth. They're about inspiring you to embrace a future filled with possibilities and helping you architect enduring legacies. Their core values of integrity, service, caring, excellence, and growth are at the heart of everything they do. Connect with them today at austinprivatewealth.com.
Austin Private Wealth is a registered investment advisor. Advisory services are only offered to clients or prospective clients where Austin Private Wealth and its representatives are properly licensed or exempt from licensure. No advice may be rendered by Austin Private Wealth unless a client service agreement is in place. Investing involves risk and possible loss of principal capital. Please seek advice from a licensed professional.
What prompted this recent AI surge, and how does academic research fit into the puzzle? My guest today is Risto Miikkulainen, a professor of computer science at the University of Texas at Austin, and AVP of Evolutionary Intelligence at Cognizant Technology Solutions. We discuss how we got here, the new digital natives, his work, and Austin's role in the future development of artificial intelligence. Risto received an MS in engineering from the Helsinki University of Technology in 1986 and a PhD in computer science from UCLA in 1990. His current research focuses on methods and applications of neuroevolution, as well as neural network models of natural language processing and vision. He's an author of over 380 articles in these research areas. Risto, welcome to the Austin Next podcast.
Oh, thanks, Jason. Glad to be here.
So, obviously, AI is everywhere. We've heard of ChatGPT, Midjourney, kind of everything exploded into the zeitgeist, basically almost a little less than a year ago. From your perspective as a researcher, has this explosion been something that's been driven by fundamental breakthroughs? Is it been that money has kind of come through and it's just been resources and scale and the models have gotten bigger, cracking the code on user interfaces, or a combination of everything, or have I missed something?
Well, it's been a long time coming. I mean, people who are working in AI have been working for decades and decades on making these things happen. And what we're just looking at right now is the tip of the iceberg. The last thing that happened in the last year or so was a breakthrough. It wasn't really a fundamental breakthrough in research or new ideas or anything like that. It was mostly just a couple of people who believed in scaling and put a lot of effort into extremely large compute using the models that we already had and have had for several years. And it was surprising that they worked so well when you scaled them up. You could not really know that ahead of time. You had to run the experiment and try it out. And even so, there were multiple experiments before it really hit the big time. And why we are now talking about it so much, why everybody's talking about it so much, is that it became accessible to everybody through some careful fine-tuning and alignment, and then making the interface available so that everybody can go and try out AI. And they did. And they found that it actually works much, much better than it ever has. And then people started thinking about where they could use it and how they could use it. And all of a sudden, AI is in everybody's fingertips and everywhere in the society. So that's exciting.
Is that the track that we're on right now? Is the fact that we're going to, is GPT-5, 6 going to be just this massive scale function that we're going to keep doing bigger and bigger models? We're having to have fundamental breakthroughs. What's kind of coming next from that then?
Yeah, well, that is one possibility, is that we can increase the scale even further. It is getting pretty expensive, and we are using almost all the compute that's currently, and data as well, that's currently possible to get. And there's been a lot of work in making this happen. It's not just an accidental experiment that happened. I mean, there were lots of planning and many different iterations went into it. So it's certainly getting tougher from here to do that. But it is one possibility. And we don't know what will happen if you add another order of magnitude, a couple of orders of magnitude, more data and compute, it's possible that there will be even more discoveries, that AI will get more powerful. My hope is that the next level is something like an AI that knows what it knows, so that it will be easier to talk with it because it understands when it goes outside of its realm of experience. Maybe it will happen with just scaling. Most likely not. It's a different kind of a skill. And there we need more research. We need another breakthrough. We need something that doesn't exist yet. And there's often a misconception about the letter of intent that researchers argued that we should stop AI research. That was not the idea. The idea is not to stop AI research. The idea is to channel more of the effort into these studies that aim at understanding what happened with the scaling rather than just continue scaling. And given how much effort goes into scaling, it might actually be a good investment, because next time then when we scale, we actually know what we are doing. So that, I think, is a more productive step in the long term. Invest in understanding and analysis, what happened when you scale, and then we can build models that are more informed, perhaps more trustworthy, instead of just simply relying on the scaling.
A lot of times we see these large scale software types of products being delivered from the enterprise and then coming down through to consumers as a kind of a second order effect. In this kind of case, with both, I think, the image generators and the LLM models, I'm seeing it going in reverse. How do you see where everybody, all the consumers are getting it first and playing with it? How do you see that affecting kind of AI innovation, right? Where the enterprise is the one who's trying to catch up, and well, how do we integrate that? How do we use that? How is that going to affect where they're building and how like the open AIs are actually innovating and using it?
Mm. Well, again, there's a lot of effort that goes into putting together a model that you can actually give to consumers, because consumers are not really well informed in what the capabilities are, but they're also fearless. They'll try anything with these models. And you're really making it vulnerable and putting it into a test in a totally different level. And I think also a lot of innovation comes out that way. People are just trying it out in ways that nobody could foresee. There's a lot of creativity that way. Now, the industry and the enterprises needs to catch up, because it's not really clear how you make money on it. How do you put it to work on existing applications? But isn't that just wonderful? I mean, you have all these things that people are discovering and using it for, and then the serious work can come from this all this sea of a lot of excitement and diversity and potential applications, as opposed to trying to do it in hiding, perhaps secretly, and with a lot of planning and with a lot of hard work. I think just the excitement factor is much bigger. And I think it results in more creativity. And there will be more opportunities for businesses to catch up. And it's not just a couple of big players in industry who can do it. There's actually a lot of opportunities for smaller startups that are based on ideas. And that, I think, is another wonderful ingredient in this current AI, that it is actually quite open compared to what research and development in industry has been in the past. That even today, some of these large language models are open source. They are open weights, I guess you could say. So people can have access to the models themselves and modify them and work on them. And there has been a tradition of AI for quite a while. A decade or more. Deep learning, for instance, started with making tools available, TensorFlow, PyTorch, and it made it possible for a lot of people to join the effort to make models better. And that has paid off wonderfully. There's a lot of excitement all around the world in all kinds of universities, industries, startups, big companies, because of that, because it wasn't closed. And that hopefully will continue. I mean, it is a kind of a dicey situation here. The biggest models are still closed, and some of them are still closed, and there's others that are open. And there's a call that universities should build their own models that would be completely open to researchers. It's not clear where it's going to go, but I think it's a really great play to have open source and open innovation in this space, because that has produced tremendous results already in AI, and hopefully we will continue that.
No, and I think I do like the idea what you said about like with the fearless aspect of the consumer having in this space. I want to tell you like a story of my 9-year-old who likes to help me sometimes with Midjourney, and he has no boundaries in this. And when he learned about negative prompting, we put in, he was like, okay, so what if we put in chicken and then put in the negative prompt chicken? What would happen? And who thinks of doing that, right? And I'll tell you, the images we got back were very weird chickens. It was like a chicken in a suit or a gigantic chicken. So we're trying to figure out what's happened. And the other day, I posted this on Twitter as well. He was giving these really odd things like, take a family and have 5 people and then 3 people putting in and this and that. And so I just said, so just based on his commentary, I put in 5 plus 3 into Midjourney. And I had castles come back. And I had this sunset image. And I've still had anybody explain to me what that was. I don't know why that came. How does 5 plus 3 turn into a castle? So, and it's only the mind of a child, only someone, as you said, someone who's fearless, who's going to be like poking and prodding these kinds of things. Like no one in the enterprise is going to be just like, let me just do really weird stuff.
Yeah, and these tools are tools for creativity. That's what they are trained to do. They are image generation models and language generation models, and there's nothing to prevent them from being creative in that way. And some people will be better at it, and it may be digital natives, the 9-year-olds who grow up with them and they know how to interact with them and be creative with them. And they can make really interesting images and perhaps stories, and where the challenge is that the models are not intended to be, say, database interfaces or payroll machines or anything that is precise and does exactly what you want. That's not their nature at all. And a lot of times that is a requirement if you build something, an enterprise. So that challenge is still something. I mean, obviously, they are like you can make them chatbots and interfaces to a lot of things because they are language models, for instance. And I mean, I'm not talking about image models right now, but language models certainly. You can make them something that allows more people to access more complex systems than before. But if you want to push them and make them do reasoning for you or make discoveries that are scientifically valid, that's not in their DNA, so to speak. And we have to figure out whether we can push them that far or have them be useful in creativity with some kind of other systems that then do the due diligence with data and with information and facts. And that's a challenge we are facing next. And I think it's pretty exciting. We wouldn't even be thinking about it if it wasn't for the 9-year-olds being so creative.
Since I'm not deeply entrenched in the space, so I kind of hear about everything through the media, I think about like 2 sets of AI work, right? I hear about what we're talking about, the big commercial applications and the things that make the big headlines, or those things being done in the research labs within those organizations. I'm thinking about like DeepMind, right? So AlphaFold, which was putting out all the protein folding, or AlphaGo. But I don't hear so much about what's going on in the universities, obviously, because that's probably done more. You hear about it more at the conferences and people that are deeper in the space. So what is going on at the universities, and how is that different from what is going on at the commercial labs and within kind of the different big organizations? How would you make that distinction?
Yeah, well, there's a lot going on. And actually, before the large language models and the DALL-E's image generation models, it was a pretty balanced effort. There were researchers in universities and in these tech companies, and they were using the same tools. They were addressing the same kind of questions. They were going to the same conferences and meeting regularly and talking about these things, which, like I said earlier, it is great to have such an open community addressing these issues. And it was new. I mean, that was not the case, 10, maybe 20 years ago at all. It's relatively new that there is such a large community, and it covers both industry and academia. But now just see what's happened is that a couple of breakthroughs that mostly industry have access to, like these large language models, the largest ones, are just now in the spotlight. It's not that the other research is going away. It's just that everybody is jumping in the bandwagon. Those who have resources can build these large language models, but it's a really small part of what's going on in AI. And it's right now the focus, and it has to be because it's so exciting and it's so new, and we try to figure out what the opportunities are. And hopefully it will be made open so that academic researchers can also work on those. But eventually, as I already suggested, that we have to understand what's going on in these models. And that's the kind of work that perhaps is more fitting for academia. It's more, you need more patience. You have a lot of false starts and ideas. I think it was actually Jeff Hinton in one talk mentioned that 1 out of 10 good ideas works. So you need to try things many times before you find something. And there are lots of people in the industry, and they can certainly afford to explore also. But academic research is often more patient, a little bit more slow paced, but can uncover these fundamental principles. And because there's not necessarily an immediate benefit from it, but it's more of a scientific curiosity that drives you. Like, I wonder what's going on here. That's really interesting. Why does that, and so on, even though you don't kind of know what you do with it at first. So that's a different role for university. And I think they can play that role and in parallel with what's going on in industry.
So, and this is I come from more of a bio background, so it's easier for me to wrap my head around basic research and applied research because of that kind of fundamental shift, and it's more discovery, right? Like, how do the laws of nature work in biology, and then you can build off of that. But when you have something like AI, we're building the laws, we're creating it, from that. So you're exploring something that we're creating. It's a little harder for me to kind of wrap my head around where's that line between basic research and applied. Where you said, where do you have that patience? What are we doing in the basic research?
That's a really good point. I haven't thought about it, but I don't think there's much difference. I mean, I do also research in neuroscience and have for a long time in cognitive science, where it's very much like that. You don't really have an application in mind. You're really trying to uncover what happens in nature. I don't think it's that different. I mean, look at these large language models. It's like an object in nature. It's like a brain of some new animal that you discover. And now you try to figure out what's going on in them. The mechanisms, the methods, the conclusions that you're trying to get to, I think they are relatively similar to that. It's the same kind of curiosity that drives it. Of course, it's a man-made information system, but if you abstract it, brain is and also an information system made by nature. But where it came from doesn't really matter as much as the questions, the challenges, the complexity that you're trying to understand. That can still be fascinating. And maybe some new technology need to be developed to do it. But there are also other fascinating opportunities. Like in the brain, it's very hard to understand what's going on at once everywhere, even see what's going on at once everywhere. But in a computational object like an LLM, you in principle can. You have access to those 700 billion weights. So it can also serve as a stepping stone to complex systems like a brain in general. If you have full access to something that complex, that large, and develop techniques to understanding it, maybe those techniques apply also to the brain and biological systems in general. So I think that there's some parallel effort, similar effort, but also differences that perhaps interactions will help. I mean, large language models weren't really developed in order to understand the brain, but the origin is in neural networks. And the origins of neural networks are in biology. So maybe they diverged, but maybe they will also in the future come together to some degree and help both disciplines.
I hear a lot about this opaqueness of these AI models, that we do it and we don't understand why they do these things. And as someone who's not deeply entrenched in this space, what is the cause of this opaqueness? Is it because it's not a straightforward algorithm? Like, why don't we see all inside and understand what exactly it's doing?
Yeah, that's precisely it. It does not follow code like Python code, and it does not have a storage like a RAM or something where you put stuff and you can later retrieve it. It's based on a very different principle. I mean, there's huge divergence of information and then convergence. Those billions of weights, say GPTs have tens of billions, hundreds of billions of weights. The knowledge that it has acquired, examples that it has seen, it's all deconstructed and superimposed onto those billions of numbers. So weights are basically just numbers, and you learn by modifying those numbers. And you modify it in a way that you can later, well, predict the next word. Or an image model, you add noise and then you remove it, and you learn weights that allow you to do that optimally. But the information is always distributed. No one location really makes sense on its own. It has to be combined with a large number of other numbers in order to make sense. And that becomes challenging because there is really no place where you can go and retrieve something. All the knowledge that it has is vastly distributed, and you have to construct the answer from those numbers. And therefore, even if this kind of a model, for instance, regenerates something that's already in the literature, in whatever, Reddit, New York Times, somewhere, say it's a piece of text and it's reproduced almost verbatim, it's not actually copied. It's not that it was saved somewhere and now it's just recalled and put out. It's actually reconstructed from those billions of numbers. And similarly, anything else that's completely new that's never happened or never been seen before. And in that sense, it's also a very interesting question for copyright because it is not actually copied and reproduced. It's actually regenerated. It's constructed. Now, that's what makes it so difficult, because you cannot break it apart and understand its elements, its pieces, its components. Now, brain, as far as we know, works quite a similar way. And we have techniques of imaging and techniques of affecting processing like TMS and other ways of modifying what the activities are. Maybe we need similar techniques in these large models. So far, and progress is being made. I'm saying that it's not understandable now, but in a few years and couple of months, we'll probably make quite a bit of progress in understanding them. And they may be neuroscience techniques, they may be new techniques. There's already quite a bit of work in understanding what happens in small networks. But the big challenge is that we had small networks since the 90s. I mean, I was part of the community who was trying to get those neural networks to do variable binding, like flexible assignment of roles to constituents. And it was really hard in the 80s and in the 90s. And now that does happen in these large models. Is it because it's just that they are large enough that some kind of abstraction and representation of relations happens that couldn't happen in smaller models? That's the kind of question we have to try to answer. And then build systems that really take advantage of those mechanisms that maybe were discovered by accident by just scaling up. So that's at the crux of this question.
Have you been able to start using, I'm really thinking about like the productivity loop itself with AI. Have you been able to start using AI tools to, whether it's learn more about the visibility into AI or just AI to help conduct research into AI? Like, has that flywheel started?
Yeah, that would be nice. I mean, that's been the dream of AI for a long time, that you build enough of it and then it builds itself. Even the site project, which was in Austin, and I guess still has some follow-ups, with the idea that you encode enough knowledge, I can't remember, with 10 million pieces or something, and then it just reads the newspaper and collects more information. And now, in principle, it could be AI that's generating more text that then it learns from itself. But it sounds that something must be wrong there. I mean, you can't get everything out of nothing. But in a shorter term, I mean, yeah, it is a tool that is useful, and I use it sometimes and for limited things, like if you've taken notes about something, you've gone to a talk or workshop or something, you take notes. These language models are perfectly good at summarizing that, writing them out so that maybe other people can read your notes too, because they are not cryptic to you necessarily. And these models are quite good at that. But remember, here you are giving them the material. They don't have to go and confabulate and make up stuff. They actually are just expressing it in a clear manner. And they are quite good at that. You know, if you are writing a paper, you may want to have some aspects of, and you're not, maybe not a native speaker, and you might want it to be easily understandable, plain English. These models can help you. They are not yet good at understanding what makes this, say, a scientific paper worth writing. So if you ask them to, for instance, write a discussion, that means bringing in-depth knowledge of your entire career, what matters, what doesn't? Why is this interesting? Why is this surprising? How can you build on it? They don't have any knowledge like that. They can't bring it in. They can really only summarize. So we haven't been able to really get them to do something like that. They're good at summarization, but they're not good at providing, say, even conclusions that are meaningful and insightful. And beyond that, you might imagine that now, with all these abilities of AI, it might be accessible to, I don't know, the general population to come up with ideas in science and have GPT to make them scientists. And that I don't think is likely to happen. I mean, you have to have the initial expertise that then you amplify with these tools in a limited sense. Whatever they make up, it is creative, but it is not based on facts, and you never know when it might be. So it doesn't make you an expert in heart surgery or nuclear physics to use a GPT. You have to have that expertise and then make it easier to communicate. I mean, that is currently the role. Even if they've read a bunch of textbooks, if you ask them to write a story about unicorns, they write a story about unicorns. If you ask them to write an article that's a scientific article about unicorns, they might do that too, even though they don't exist. And then no scientist would do it, but a citizen scientist might if they don't know better. It doesn't have to be unicorns. Citizen scientists will know about unicorns, but something else that's within the realm of possibility, but not real. And that is a big challenge, whether we ever will be able to close that gap. Not with current models, but it's possible that with an extension and maybe in combination with other research that's going on in AI, it might become possible in the next few years.
I think I'm going to challenge you a little bit on that, and I think it's coming faster than that. And I think we had an interesting conversation a few months ago with I had Brett Hurt and William Hurley, better known as Worley, on the podcast. We were talking about Gen AI and a few other things, and something he said, Worley said, that kind of really stuck with me was, Gen AI is going to help with power the rise of the non-creative creative class, is the way he put it. All these people had these different business ideas, and they could never how to kind of put it together. And this was a great way to kind of push it forward. And one of the things that had kind of sat in my head was what you had alluded to, right? Was, is there a way with the educational potential of AI, and I think about all the stuff that the people at Khan Academy are integrating into their systems, and the co-pilot capabilities. You mentioned expertise a number of times, but is there a way to supercharge getting that expertise into people's hands? I don't think it's not a outsourcing the expertise, but how can we teach faster? And the decentralization, lower cost of some of these research. You have cloud labs and different capabilities. I start envisioning the rise of this non-scientist researcher class, right? As you said, the citizen researchers, and starting to ask some of these questions and bringing these different angles. You have and I'm forgetting his name off the top of my head, but the very famous Indian mathematician who just learned got the books and learned everything, and obviously he was at the genius level and was able to kind of take things in. But how many people do we know who are out there like that, who aren't giving access to these types of tools and different questions? And I think it does make an interesting possibility that there are people who are interested in these ideas, that you have YouTube and you have these different, yes, I can go take a class, but this creates a whole new level of learning capabilities. And it is one thing right now, to your point of, I go ask ChatGPT, teach me something. It's another thing when Khan Academy builds a AI tutor where they know and understand how to teach.
Well, yes, I absolutely believe that there's a role and there's a empowerment, an opportunity here that make teaching better, make learning better. Now, the non-creative class, yes, I mean, creativity, at least at the level of, say, creating images and writing, been empowered a lot. I mean, people who, I couldn't make a painting, but I could, with a paintbrush and paint. But these tools allow generating images I'd like to generate. I mean, I'd be creative in conceptual level, but not have the technique. And now it gives me the technique and thinking visually, creating illustrations. Same thing with stories, perhaps. I mean, I could outline a story and have GPT write it. And that is creativity. I mean, you still are the creative engine there. you come up with the ideas and you have GPT as your tool. It's much more than, say, a grammar checker, but it is in that same category of helping you generate better output. So that's one aspect of it. Learning, I think there's also a role in that. It has to be based on actual real materials that are factual, so that GPT wouldn't generate just examples out of thin air that are not true at all. But it could make, if it has access to, for instance, through some kind of a tool that we don't necessarily currently have, a lot of people are building interfaces between GPT and various databases, actual factual knowledge, even just the web. I mean, there are APIs now that GPT and these large language models can use. And in that sense, they can actually retrieve real knowledge and then display it and write it out. So they could, and they can take different personas. So they can, for instance, express something in a very simple language. They can express something without using the letter T ever. I mean, silly things like that. But also, more importantly, actually take the background of the learner into account and express the example or the exercise in their terms. For instance, I'm just thinking out of my head, and I think that Kanak and many others are probably already working on things like that. And it makes these tools a lot better. They're much more effective. They are customizing learning and teaching. The original plans and the materials and the course organization and things like that still have to come from experts who know what they're doing. But they have now a very powerful tool to customization and making it more accessible and more effective, I think. And what I was talking about earlier is trying to use them to generate content when you're really trying to do it from nothing, when you're really trying to confabulate or hallucinate. And that's where the danger is. I mean, it's not really a danger. I mean, we know that that's a problem. So as long as you take care of it and make sure that you are paraphrasing and making accessible, using different personas on knowledge that already exists and has been vetted, I think that can be handled. And then in the future, the question is, how far can we push it? How much more power can we get out of these models that's actually based on facts or recombination of facts? And that remains to be seen. We'll probably make progress in that direction, but it will probably also require using other techniques in AI and not just these models that learn to predict the next word, but actual access to databases, actual logical reasoning, actual discovery and search for solutions come to mind as some of those techniques.
Oh, yeah, no, the hallucinations are a whole interesting thing. When Bard first came available, I had a fun little trip asking it about Austin Next and what it knew about its host. And that was interesting. Apparently, we had New York Times articles written about us and millions of downloads, which I'd love for that to be true. And it was making up quotes about that we had said, and all these guests that had never been on. And while it was really funny and interesting and to kind of go through that process, but you can imagine that in situations that weren't as humorous.
Yeah, but notice though that what it's designed to do is to, again, predict the next word, which translates to creating good articles. That was a good article. I mean, it was like an article about unicorns, but it was about a real thing as a starting point, and then what a good article would look like in this space. So you can't really blame it. It's doing what it was designed to do and doing it really well. It's our job now to figure out, can we actually utilize it to do something useful, something that we can trust? And that's work that remains ahead of us, and eventually we'll hopefully get there. Not just today, but it's a good starting point.
So I want to kind of take us from like the macro stuff going on in AI and kind of bring us down to your work in particular. And for someone with clearly a non-technical background, can you describe your work and the research that you're doing?
Well, yes, of course. And how many hours do we have? I mean, this is a topic that's very easy to talk about and fun. As many academics who've been around for a while, you develop multiple different areas and they are connected in your head. And then you try to make a cross-pollination happen. So I started with cognitive science and natural language processing, but a different kind, not the kind of large language models that we have today, but models that would explain why people are good at language. And when they have breakdown of language due to stroke or dementia or some other issues, how did this happen and how we can rehabilitate. And that's work that's continuing today. We've been working on it for decades. And I have collaborators like Swati Kiran in Boston University and earlier Ralph Hoffman at Yale on schizophrenia. And we are using the models to think about these problems. And with Swati in particular, the idea is to build models that replicate an individual patient's situation, their language history, their impairment, and then we can use the model to test different alternative treatments, like how do you train them post-injury, rehabilitation, and find out how to do it better. So we use a computational patient as a digital twin for the real patient in order to help the real patient more effectively. And this is the first time that such digital patients have been in a clinical trial. We just finished a clinical trial and an NIH kind of sanctioned clinical trial and analyzing the results. In the future, this could be a mechanism for customizing medical treatments. Now, so that's one big area. And we're also working with a company, Cognizant Therapy, who has years of data on rehabilitation of stroke victims and dementia patients, people who have trouble with, as a result of the injury. It could be language, it could be naming, it could be even writing, other kinds of dimensions. And with that data, we can try to search for better treatments. And that is, first you build a model of the patient again, but then you run the search. And if the space is large enough, we can't just try everything, every possibility. And we bring in a search methods called evolutionary optimization, where you have a population of possible treatments. And then you are recombining the good treatments, throwing away the bad treatments, trying to run the search like biology optimizes different niches for living organisms. And this is a very powerful mechanism when you have a huge search space, typically larger than the size of the universe in terms of particles. You can still find good solutions using this kind of population-based search. There's a wide cast of characters, and you are trying to find the good ingredients and then recombine them, create some new ones, and this way you find good solutions. And that's what we're hoping for, even in this medical treatment domain, that some of these treatments interact. You first, for instance, name some pictures, and then you write some poetry maybe, or you are challenged with mathematics, and there's an interaction that happens. And we don't understand necessarily how and why they work. But if we actually have enough data on real patients, we can learn what works. And we can learn how those interactions can be maximized. And that's what we are getting at. So that's a big part of my research right now. Notice, though, by the way, that it is different kind of AI than the large language models and diffusion models. It is based on search, which I think will have to be brought into the language model world as well if we want to optimize their usage and understand them. And also models that are motivated by the brain structure and cognitive science, not learned from scratch, not human cognition zero, but actually you start with an architecture that you already know to some degree exists in the brain, and then you see what you can do with it. So the computational neuroscience perspective and the search perspective are different from the currently hot large language models and diffusion models. But also, so are the goals here. We are not trying to build a chatbot, but we are trying to understand how to help people.
I'm trying to understand in this case where you're looking at all of the different interactions. I'm assuming all of the interactions haven't already taken place. So you're having to make different inferences, like A and B have occurred, B and C have occurred. I mean, really simple here. And given those interactions, we think A and C will interact in this different way, but then scaling that up to a billion different permutations. And that's what the AI is looking at, if I got it at a really basic level.
Yes, that's exactly it. We assume that the world has some regularities, and there's plenty of evidence that there are such regularities. So when we see in these samples, then they are like points in a very large search space. We're trying to find points in there that are really good, that are like exercise definitions that work really well. And we've seen a couple of points there already, maybe, and not more than a couple, hundreds of thousands. So we have some idea how the space is structured. It's not uniform. It's not the case that treatments can cover all the possible combinations. They don't even make sense necessarily. And it's not the case that in a random location in that space, there's something good. There are some principles. So if you have good treatment recommendations, some modifications of them nearby will probably also work. And the idea is that there's some continuity that you can try to understand. That, okay, if I keep adding the intensity into this naming task, but at the same time, keeping also the mathematics, I will find something more powerful. That there's an interaction, and we already have a hint of it in the data that we do have. And now what we do as a first step is to build a model of it, a model of those interactions, a model of what that space looks like. Even though we only have samples of it, we build a model of the whole space. And now we can go and query this model. We don't actually test the suggestion of this search engine in a real patient. We don't have to, because we have a model. We can ask the model, do you think that this would be a good exercise that would have good outcomes on the patient? And the model may tell you. And it may give you enough information that you can then search more effectively other variations. So that's the main idea, that there's a model of the world. We call it a surrogate model. It's a surrogate of the world that allows you to test a lot of different ideas very quickly without having to involve the patients, without any cost in the real world. And then when you can search for millions or possibly billions of different alternative treatments in this space, and therefore find something that you wouldn't find yourself as a human researcher or clinician, or even by just trying to generate them from scratch and testing in the world. That's the basic idea of that. So yeah, absolutely right. Not all of them have been tried, but if enough have been tried to give us the model, then we can find better ones automatically using AI.
So when you say you're building a model, and this may be a very low-level question here, I think there's obviously the rule-based models where you're being very prescriptive of the structure of the world. But then as we think about like the neural nets in my, obviously I'm thinking really abstractly here. How are we thinking about when you're building the model? Like, what is the framework that you're creating of the world, right? How much of it is very specific of here's how it looks versus more of allowing it to kind of build itself?
Yeah, and that's a really good question. We talked about trustworthiness earlier, and that is still a big question everywhere where you have machine learning. Now, it turns out that these neural networks are very powerful. So you get behavior, performance first, and understanding is not that great. I mean, you don't really know what the neural net is doing, like we talked about. This divergence and then construction happens in these neural network models. But for instance, in this case that we talked about, the rehabilitation, the model of the patient does not have to be explainable as long as it's predictive. So it can perfectly well be a neural network that simply predicts how well the treatment will work. We don't have to understand at that level of modeling. Now, then we are discovering what the treatment is doing. Again, the treatment, usually it's composed of elements that we understand and how they put together. All we're learning is how effective they are. But at that point, once we get there, we discovered something. We might want to understand some principles of why it's working. Why are these elements important in it? And what if we replace something with something else? Would it still work? Have not just the performance and trust me, I know what I'm doing. That's what the neural net is telling you. But actually say, I'm doing it because of this. And now we need to use different techniques. And indeed, you mentioned rules. It's perfectly possible to evolve a set of rules instead of evolving a neural network. And we've done plenty of work on that. I mean, I didn't get to it, but my second current main area is really this evolutionary optimization, population-based search in general in problem solving, not just in medicine or healthcare, but solving problems in businesses, in science, in design, engineering, using evolutionary search to find good solutions. It's much more general than healthcare. And there it turns out that explainability is quite important. I mean, if you are investing money, it might be marketing, it might be stock market, it might be something else. You want to understand what it is. But same thing with patients. If you're actually prescribing medication or prescribing something that potentially can be harmful, you better understand where that's coming from. And we have several examples of, say, diabetes medication and minimizing hospital stays and so on. Now, it turns out that in cases like that, it's important to have explainability. And we can, instead of evolving a neural network or training a neural network to do it, which is opaque, we construct a set of rules. And now a human can look at those rules. And a human expert can see what variables they are taking into account. For instance, blood tests or behavior measures or something that is tangible, that's actual clinical, has clinical meaning. And then how the rules take those into account and what conclusions they make. And an expert can validate that actually makes sense to me, or I don't know where that's coming from. I'm dubious about it. Let's turn that off and see what happens. And they can edit those rules. They can add their own knowledge also into this mix, knowing that something is missing, this variable needs to be taken into account. You can even handwrite a rule that augments the set that was automatically discovered. And in this manner, we can actually develop, they're still models, but now they are rule-based, and they are transparent and explainable, and more likely to be deployed because they are something that the expert can follow. Now, that technology does exist. It's not yet at the level that it could be deployed everywhere and all over, but we're definitely working on it and hope it to become possible, because I think it's a crucial element that's missing in a lot of AI today. And there's no reason why we couldn't put it in. I think that would be a major step.
So you mentioned with this collaboration, you were working with people in Boston, I think you said Yale, so collaborating with people all over the country. Obviously, I focus a lot in some of the conversations, this is about a lot about the Austin innovation ecosystem. So one of my kind of first questions, and I say kind of cheekily, right, is why aren't you collaborating with people in the Austin ecosystem? And I mean it more that what do we need to do to help build more bridges and better connections? So the first thought a UT researcher has is looking at the local innovation ecosystem.
Yeah. First of all, that the world has changed, and pandemic had a lot to do with it. It was changing already. I mean, we started to have a lot of remote collaborations that were powered like orders of magnitude by video conferencing, that you can actually communicate in a very interactive, creative way using video conferencing. Even before the pandemic made it now, instead of an hour, a couple of hours a week, you're doing 13 hours a day of video, which wasn't necessarily healthy, but we did get a lot of work done that way, and we know how to do it now. And that has made it possible to collaborate much more broadly. But it hasn't taken away the importance of personal contacts and actual, being in person, in a room, at a whiteboard, and, contributing the same drawing. There's some digital tools that could do that, but it's still quite useful. There's also the personal contacts that you need. I mean, just to know your collaborator, like where are they coming from, what's their background, what is their interest. Zoom time is always scheduled, and you don't have time to chit chat. Some of this chit chat is important. I mean, it's important to know the people and their thinking. And if you're just always focusing on the first practical problem that's in front of you, you don't really get it. So these personal contacts and personal brainstorming sessions are really important. And we have to do them. I mean, even if we are remote. I was just in Boston just 2 weeks ago because of this. So we could do an in-person session. And I think it was really worthwhile, and it has a different depth. Now that we had it, we can go on for months with just video. So now that's why also I think that most immediately, if you are thinking of a potential collaboration, you first think of people that are nearby, that might be in my case, UT Austin or in the Austin area in a, say, healthcare industry, because if that's a domain, because it just makes these in-person interactions much easier. And I must say also, Swati was at UT Austin a decade ago or longer, 2 decades ago. That's how we got started. She moved and we continued. So this started from a local collaboration, this whole topic that we've been talking about today. And I wouldn't discount it. I mean, she just was working in the next door, and we had a talk in Austin where we both were and started talking. I mean, these kinds of situations happen. So that's one thing. We have to bring people together. We have to have these common events. They might be meetups. They might be common talk series. They might be workshops on campus. And that is taking advantage of actually what we have in Austin, which is a lot. We have a very large university. We have a medical school now. We have high-tech industry. We have a lot of startups, a startup ecosystem. So bringing them together into these events and making it possible for these happenstance serendipitous interactions to happen is very important. And South by Southwest, that's more global actually, but even there, you learn about what the guy next door is doing because you go, and that happens too. I mean, we go to conferences and I only find out about a colleague of mine what they're doing because we happen to be on the other side of the world in the same conference, and then start collaborating. You seek out these opportunities. So yes, I think there's a great opportunity. It's important, but we also have to foster it, and you cannot quite prescribe it. It has to be, you have to create a lot of opportunities for these accidents to happen, and they will then. And I think people in Austin are generally quite open to that. So it's also a good atmosphere for doing it.
Yeah, I call them creative collisions.
Yes. Okay, great term. I have to remember that.
So I want to take now almost the flip side of it, right? We talk about how we kind of have things locally and going, but thinking about remote, UT Austin recently launched their online master's program in AI. This is the third program with computer science and data science. So kind of first question, how do you think this kind of positions UT as like the premier institution for AI? Does it? I mean, where do you think this does for the university?
Yes, it's absolutely important to create these opportunities as well. This is more of it serves a couple of purposes. I mean, first of all, it is a global reach. I mean, anybody can sign up for this in the world. You don't have to be local to Austin and then have access to experts that are at UT Austin, in this case in AI. And other universities have similar opportunities as well. And I think it's really, really great that, you can be an expert in your field, but if you only talking to folks that are next to you, you might not have the reach. There might be somebody else further apart, somewhere else who wants to work on this area but does not have access to it. I think it's really wonderful that these opportunities now here. We have a large faculty in AI, so it makes sense to build it. We have a critical mass to do it, but it also serves. You mentioned citizen scientists, people who actually are not able to become full-time student for many reasons. They might have to actually, they can leave their job, or they can geographically do the commute or move to campus. They may be older students who have other demands on their life, and and this kind of education becomes available to them as well. So it's really broadening the participation, bringing more people, the expertise to more people than otherwise would be possible. So I think it's really serving a need. And now also because of the pandemic and people are very familiar with remote work and connections, it's much easier to do. And we have now developed tools that allow us to deliver the material and engage people and have the people engage in discussions and make it live. So I think it's also become much more effective. And there's also a lot of opportunities to use AI to do this better and all aspects of it. So it is an industry that is I believe will be growing quite a bit. And it's also important for us to do it so that we stay in the spotlight and we have reached to a broader audience for recruiting students and faculty and also making these connections that you mentioned. For research that they may be local, but sometimes they are not, and having us be on the map that way when somebody thinks of a good idea and realizes that at UT Austin there are people who work on it. We got to be there in their minds. So I think this kind of exchange is very important, and it's new. And since we already have done it in 2 different programs, I think the AI is already hitting the ground running, and we have a lot of traction on it. And it's building on some courses that already exist. There's some overlap, but there's also now opportunity to take advantage of all the expertise that we have at our faculty. We have 20 plus AI faculty now, and it's only going to grow in the future. So I think it's pretty exciting.
So you mentioned that it's good for branding and recognition, and it has this global reach. Do you see it having an interplay over the long term with the Austin talent pool? Do you see people who are maybe taking it globally but end up having this kind of attraction eventually to coming to Austin? I mean, do you see what do you see as the kind of the second and third order effects of this?
Yeah, there can be such effects. I mean, for instance, the students do interact in some manner in these courses. They form smaller groups, work together on projects and so on. And there are students from Austin who are working, say, North Austin and various high-tech industries, and making these connections. They might get hired. They might move. That's perfectly possible. it's all about creating these connections as well. It's not just learning the material that's already there, but knowing the people, knowing the opportunities. And I think we can do that even in an online setting. So that's definitely a secondary aspect of it. But also the businesses and industry in Austin might encourage their personnel to take some of these courses because they are easy to do, even if people are in Austin, and we get better workforce. But that's because it is a course at UT Austin, and they might know the professors, and therefore might be more likely to take one such a degree, for instance, AI masters in Austin, because it's nearby, it's known, and you also can then get excited about what's going on and go to these meetups and various events, talks on campus, for instance. And there's this long-term effect that also accumulates. It's not just training a particular group of people. So I believe you're absolutely right. There's a long-term effect as well, and Austin might should benefit from it.
Well, this has absolutely been an education for me. We always end with this same question: what's next, Austin?
Yeah, well, Austin is at the forefront of AI and technology in general, of course. But like I said, we have lots of faculty and bright students who are learning about AI. And I believe that now there's great opportunity to do startups, take this research to industry and other opportunities. So, and Austin has a thriving startup community that hopefully will grow as a result of this, because there's an alignment of interest. We have lots of work going on in AI, a startup community. And also one more factor is the medical school that was started, UT Medical School. Didn't exist for decades when I was at UT. Now it does. And there's great opportunities, even for this large language models and generative AI in that domain, healthcare, medicine. So that would be my bet. Try to encourage the AI folks and the medical folks to get together and identify these opportunities. Perhaps the students will find ways to create startups on the medical space and using AI. And that could be something that becomes a strength in Austin, and we can become a world leader in it.
Fantastic. Risto, thank you so much for joining us.
Yeah, this was my pleasure. This is really fun. Thanks a lot, Jason, for inviting me.
So what's next, Austin? We're glad you've joined us on this journey. Please subscribe at your favorite podcast catcher, leave us a review, and let your colleagues know about us. This will help us grow the podcast and continue bringing you unique interviews and insights. Thanks again for listening, and see you soon.